All right, so today is part 2 of the test 4.3 review. So we've had part 1 yesterday, part 2 today, and then tomorrow will be your test. So this is the remaining topics that will be covered on the test. Like I said, there are 12 topics total, and so we're going to go through 2 problems from each topic, and then you have 2 problems to review yourself. That will be very, very similar to the ones that I'm doing. So on this first section, we are graphing radical functions. So remember, when we graph our radical functions, our parent function is depending on which type of radical function, either the square root or the cube root of x. So first thing we're going to do is list our transformations. So I have that minus 3 on the inside. On the inside, we always think opposite. So that's going to be a horizontal shift to the right. Then on the outside, the minus 5, we're going to take it as it is, and it's going to be a vertical shift down 5 units. So I'm going to graph the parent function for the square root of x. So it's y equals the square root of x. And then I'm going to graph the new function f of x equals the square root of x minus 3 minus 5 by taking these 3 points and moving them to the right 3 and then down 5. So that is my new function, and we'll do the same thing with the cube root. So with the cube root of x, we are going to take the transformations the same way. So on the inside, our transformations will look like the opposite. So on the inside, opposite means a horizontal shift to the right. Four units. And then that plus 2, we take it as it is, so that's a vertical shift up 2. So then for our cube root of x, I'm going to graph the parent function as well. So that's our parent function, y equals the cube root of x. I'm going to take each of those points and move it to the right 4 and then up 2. And I'll connect those points. And that is my new function, f of x. So make sure that you are comfortable with listing the transformations that are happening to a graph. We're going to do the same thing, but now with the cubic function. So we have our radical functions and then the cubic function. So our parent function is y equals x cubed. From that parent function, the transformations that I see are 1 on the inside, which is the opposite. We've got a horizontal shift left 4 units. And we have a vertical shift with that minus 1, down 1. So I'm going to graph my parent function. So that equals x cubed. And then I'm going to apply those transformations to it. So I'm going to take each point and move it left 4 and down 1. And then connect those points. And that is my graph of f of x. Same thing with the next example, we have a negative x cubed plus 3. Whenever there's a negative in the front, then that's going to be a, excuse me, a reflection across the x-axis. And that plus 3 on the end is a vertical shift up 3 units. So again, I'm going to graph the parent function here. Take each of those points and apply those transformations. So we're going to reflect each point across the x-axis and then move it up 3. So then that is our new function, which is f of x. So then you'll do the same thing with the following two examples. Then our next topic will be graphing inverse functions. So we want to find the inverse. Whenever we want to find the inverse, we're going to switch our x and y variables and then solve for y. So this is y equals the cube root of x minus 1 plus 2. So in order to find the inverse, what I'm going to do is switch these variables, like I said. So this is now x equals the cube root of x minus 1 plus 2. Oh, I put x twice. So I'm going to, I did it again. Y minus 1. There we go. Okay, so I'm going to solve this for y. So x minus 2 equals the cube root of y minus 1. And I'll cube that. And I get x minus 2 cubed equals y minus 1. Add 1. And so my inverse function equals x minus 2 all cubed plus 1. Do the same thing with the next one. So we're going to switch our x and our y. So I'm going to start by writing it as y equals, since it says f of x. And then I'm going to switch those variables. So x would equal negative 20 plus 8y over 5. And then I'm going to solve that for y. So first thing I want to do is multiply everything by 5 so I can get rid of that denominator. So we get 5x equals negative 20 plus 8y. Add 20. 5x plus 20 equals 8y. Still want y by itself, so I'll divide everything by 8. And so I get the inverse function of x equals 5x plus 20 over 8. So I just left it that way, since that's the way they gave me the original problem with a 1 bar fraction. So I did the same thing with my answer. Then again, you have 2 problems to do that mimic the format of the examples that I just did. The next problem set is finding zeros of functions. So on these first ones, we want to find the zeros by factoring and then solving for each factor for x. A lot of you on the last test struggled with factoring with 4 terms. So whenever there's 4 terms, split the problem in 2 and find the GCF on both sides. So the greatest thing I can take out of x cubed and x squared is an x squared. That leaves me with an x and a negative 4. Whatever I'm saying it leaves me with, whenever I distribute that x squared, I'll get x cubed from the x squared times x, and then negative 4x squared. And that's exactly what I started with at the top right here. And that's what I want. I want it to be the same. I just want to take out that x squared. So then on the other side, remember whatever sign is first we take. And so we're trying to find a GCF for 4x and 16. And so we're going to take out a negative 4. Then to get from negative 4 to negative 4x, I still need an x. And to get from negative 4 to positive 16, I would need to multiply by a negative 4. These have to be the same. So it leaves me with x squared minus 4 and x minus 4. And so I see a square in my answer, so I'm going to check, can I factor that further? And since this is a square, I'm looking, do I have a difference of squares? So since x squared is squared, I know that's a perfect square, and 4 is a perfect square. So whenever I take perfect squares, 1's plus, 1's minus. And I just kept this one in my answer. So that's my factored form of the function. And so when it says to find my zeros, I'm going to take each one and set it equal to 0. So x plus 4 equals 0 means x is negative 4. X minus 4 equals 0 means x is positive 4. And again, x is positive 4. So my zeros of that function are negative 4 and 4 with a multiplicity of 2. We'll do the same thing with the next one. We're going to factor with 4 terms. So when we factor with 4 terms, we split it down the middle, and we take out a GCF on both sides. So the greatest thing that I can take from x cubed and x squared is an x squared. I would still need an x and a negative 1. On the other side, I drop that sign. Between 2x and 2, I can take out a 2. So whenever I take out negative 2, I still need to multiply by positive x and negative 1. These are the same. X squared minus 2 times x minus 1. I see squared in my answer, so I gotta check, is this a special case? I have negative 2, so this looks like it's going to be a difference of squares, but 2 is not a perfect square. If I take the square root of 2, I'm going to get a decimal. So I'm going to take these as they are, because I cannot factor any further, and set them equal to 0 to find the zeros of this graph. So I'll add 2. And I get x squared equals positive 2. And on this other side, I get x equals positive 1. So with x squared equals 2, I need to take the square root on both sides. And I get x is positive or negative square root of 2. And then you have 2 problems that are very similar to what we just did. Then the next examples that we're working will be key features of inverse functions. So remember, whenever we find the inverse, we are switching x and y, and then we are solving for y. So this is y equals the cube root of x plus 2 plus 2. So I'm going to say, well, x equals the cube root of y plus 2 plus 2. We'll subtract 2. X minus 2 equals the cube root of y plus 2. Cube everything to undo the cube root. X minus 2 all cubed equals y plus 2. Subtract 2. We cannot subtract inside there, so we ended up with the inverse function is equal to x minus 2 cubed minus 2. So the domain and the range. The domain of the inverse, which is what we're finding, is the range of the original. And the range of the inverse is the domain of the original, so they are opposites. So whenever we have a cube root function, it looks like this, which means we have all real numbers for both, and so whenever we switch, it's going to stay the same. So my domain and range will still be all real numbers. And then the x-intercept. When we find the x-intercept, we are putting a 0 in for y. So the 0 equals x minus 2 cubed minus 2, and we're solving that for x. So the 2 equals x minus 2 cubed. Take the cube root. So we get the cube root of 2 equals x minus 2. And so the cube root of 2 plus 2 is equal to my x. So the x-intercept, I'm going to have enough space, is the cube root of 2 plus 2, comma 0. And then my y-intercept I get by plugging in a 0 for x. So if I plug in a 0 for x, we have y equals 0 minus 2 cubed minus 2. 0 minus 2 is negative 2. Negative 2 cubed is negative 8. Negative 8 minus 2 is negative 10. So the y-intercept is 0, negative 10. We'll do the same thing again for the next example, but this time we've got a fraction there. So we have the function 2n minus 4 over 3. We're going to find its inverse. And if you struggle with finding the key features of the inverse, you can always graph the inverse and see what those key features are. So you can graph the new function and say, okay, what's my domain, what's my range, etc. So I'm going to get rid of that fraction by multiplying everything by 3. I should say x, and it says n, I'm sorry. So 3x equals, well, now I should say y. I'm just messing up all over the place. There we go. So 2y minus 4, and 4. 3x plus 4 equals 2y. Divide by 2. And we get the new function 3 over 2x plus 2. So we have a line that we are graphing. And so the domain of a line is all real numbers. And so is the range. So we wouldn't have to flip them since they are exactly the same. And then the x and y intercepts, we know the y-intercept is that last number, which is 2. So 0, 2. And then the x-intercept we find by setting it equal to 0. So 0 equals 3 over 2x plus 2. Subtract 2. Negative 2 equals 3 over 2x. We'll multiply by the reciprocal. And so negative 2 times 2 thirds, negative 4 thirds equals x. So then my x-intercept is negative 4 thirds, 0. So then you have two problems to do, just like the other ones, where you're going to follow the model of what we did. And then lastly, we have writing polynomials from 0. So in each of these, we're writing in factored form because that's what you need to do on the test, not in standard form. So we're going to write our function with the zeros negative 1, 3, 4, and negative 2. So we would have a function f of x. Negative 1, I'm going to take the opposite to make my factor, x plus 1. 3, I'll take the opposite, negative 3. 4, the opposite, negative 4. Negative 2, the opposite, x plus 2. And since it says to write it in factored form, that would be my final answer. And on the next one, the same thing. It says to write it in factored form. So whenever I have a 0 that comes from 0, I know that's just an x. From 4, I need the opposite, so negative 4. 3, I need the opposite, negative 3. And then 1/4, I'm going to take x equals 1/4. And I want it to look like x equals 0, x with some stuff with it equals 0. So the 4 will come to the front with the x, and then I'm going to take the opposite sign of that top. So 4x minus 1. So let's see if that worked. Would I get x equals 1/4? I'll add 1. 4x equals 1. Divide by 4. And x equals 1/4. So anytime you see one of those fractions, take the bottom number, put it with x. The top number, take the opposite sign. So like this next one that y'all have to do with 1/2, take the bottom number, put it with x, opposite sign of the top. 2x minus 1 will come from 1/2. So that's just a little trick there with those fractions. And then, just like yesterday, the remaining 12 are for you to do for your review. And make sure that you turn in the completed review on Canvas, study up tonight, and then you will be taking your test tomorrow. So good luck on that. And then if you need anything at all, feel free to shoot any one of us an email, and then we will get back with you as soon as we can.